Hi there, and welcome to today's class. Let's look at the next concept called let's look at the next concept under the study of equilibrium of a particle. So we'll take this second example under equilibrium of a particle. If it's your first time in this channel, I want you to hit the subscribe button, subscribe to our channel, leave a comment, and share this video to your friends so they can learn too. So let's solve this second problem under the study of equilibrium of a particle. The question attached to the diagram says, if the cylinder at A has a weight of 20 Newton, determine the weight of B and the force in each cord needed to hold the system in equilibrium. Position shown. So this is the diagram I have to that question I just read. So let's try to solve the problem. So we are asked to find the weight at B. Weight is in Newton. So I can say weight and force are similar. Why? They have the same unit. Newton. So it's more like saying I'm asked to find the Newton force here or the weight here. No problem. The next task says that I'm asked to find the tension for each cord. This rope you are seeing here, or let me call it, you don't call it rope, call it cord, right? So this cord EG, I'm asked to find the tension. Also, this part here is C. I'm asked to find the tension force of CE and also CD. This rope here, I'm asked to find the forces that are acting on them. My very first task says that if you observe in this case, we have 2 points. Like I have this weight attached to this point C and point A. So the only task is that I will have to pick each joint and solve separately. So if I focus on joint E first, if I pick out joint E, what will I see? If I pick out joint E, I'll try to draw the free body diagram of joint E and solve. If I pick out joint E here, I can only find tension force of EG and what there and EC. How good? If I pick out this joint E, I can only find the tension or the cord tension of EG and also EC. If I now pick out joint C, I cannot find the tension force of CD. Right? That's the idea. So I'll focus on joint E now. So I'll pick out joint E and draw the free body diagram of joint E. So pick out joint E. Pick out joint E. For this joint E, what am I seeing? I'm going to draw out the free body diagram of joint E. So for joint E, this part, this dot here, I'm seeing this dot here. This is coming down, so I'm going downward. Of course, 20 Newton. 20 Newton. Now, here's the idea, please. If I have this way, and I have my north concept, this is my north, west, east, and south, right? Now, observe the same thing here. If you observe, this one is going this way. So I'm having a force going this way. So I'll call this one, this line, this rope here, I'll call it EG. That becomes tension force of what? EG, right? And it is inclined to the horizontal. Sorry. Now, if you observe this place very well, this line I do here, observe that if I have a Z shape, if I have something of this nature, the angle here is same thing as what? The angle here. Observe this is giving me Z shape 1, 2, 3. The angle here is same as what? The angle here too. So here is also 30, right? So I can say that this part here gives you 30 degrees from here, right? Let me just draw the cardinal point this way. All right. So I have this way. Next up, observe that this also is giving me Z shape. Observe Z shape. Observe Z shape. This is the idea of alternate angle. Whatever is there and here will be the same. So I'm having 45 here. Of course, there's what? Also 45 degrees. So it means that this one goes downward. So that goes downward. That's EC. That's TEC. Tension force at EC. The angle here to the horizontal is what? 45 degrees. 45 degrees. All right. So I've carved out, perhaps I've drawn the full body diagram of joint E. So this is joint E here. Let's solve joint E. Let's get the value of TEG, and of course TEC.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
All right, to get the value of TEG and then TEC, I have to apply the condition of equilibrium. And so there are three conditions of equilibrium. So these are the first one there. The first condition says summation of horizontal component. All right, that is summation f of x equals 0. Now let's get summation of x. Please, yes, I there. Listen. If I resolve applying vectors in 2D resolution, if I resolve TEG to the horizontal, observe please, I'm doing horizontal. If I resolve this to the horizontal, because the angle is not to the horizontal, it's not cos, becomes sine. So in this case here, I'll have TEG, of course, sine what? The angle is of course 30. That's the first thing I have. If I resolve this man to the, if I resolve TEG to the horizontal, gives me sine. Now, if I come down here, if I resolve this one to the horizontal, it gives me cos because the angle is of the horizontal. This one gives me cos. But we said in this quadrant, both x and y are negative. So I'll have a negative. Resolve this to the horizontal, that gives you TEC, of course, cos. The theta is 45, right? Equals 0. Right? So if I resolve this one here and resolve this, there's no longer any horizontal forces there. So that's equals 0 there. As you can see, my next priority now is that I want to get TEG and TEC. What do I do? Of course, I have two unknown in this equation. Whenever I have two unknown, call it equation 1. All right, so from here, call this man equation 1. Call it equation 1. Right? Now, next task there, the second condition of equilibrium says the summation of vertical component, that summation of f of y equals 0. If I resolve TEG to the vertical, gives you cos. That gives you TEG cos theta here is 30, cos 30. All right. If I resolve this TEC to the vertical, that gives you a negative TEC sine because the angle is not to the vertical, it's to the horizontal. So if I resolve this to the vertical, that gives you sine. That gives you TEC sine. The angle is 45. That gives you a 45 here. If you observe this place here, this one is going downwards. So going downwards, that gives you a negative. That gives you minus 20. Minus 20 equals 0. Take 20 there. That gives you TEG cos 30 minus TEC sine 45 equals 20. Call this man equation 2. So I'll solve equation 1 and 2 to get TEG and TEC using the idea of simultaneous equation, right? So picking out the two, equation 1 has this. So TEG sine 30 minus TEC cos 45 equals 0. Call this one equation 1, as we said here earlier. Repeat this one down, equation 2. That gives you TEG cos 30 minus TEC sine 45 equals 20, please. 45 equals 20. This one here gives you equation 2. So my task here is simple as I'll make TEG subject from equation 1. So from equation 1, if I make T subject, it means that I'll be having this one move this way. That will give me TEG equals to this one move here. That gives you a TEC cos 45 all over sine 30. Sine 30. So just try to make TEG subject. You'll be having this expression. I'll call it equation 3. Alright, I'll call it equation 3. From here, let's get TEC, TEG, please. So take this off. Alright, from here, I'll now put equation 3 into equation 2. Right? So put equation 3 into equation 2. So I have equation 2 says TEG. I will say TEG is everything here. So everything here first, that gives you TEC cos 45 over sine 30 eh? No, I didn't say anything. Eh? No, you have it. There, this is what it is to use. You can come inside here. Yeah. Thank you. Yeah. So from here we send TEG. TEG is this expression. So this expression should be here as TEG. Then have a cos 30. That gives you cos 30. Then minus TEC, of course, 75 sine 45 equals 20. So if we take my calculator and punch the values, let's see what we get. So I'll simply place cos 45 divided by cos 30. Let's see what we have. Or perhaps cos 45 times cos 30 divided by sin 30. Let's see what we get. Cos 45, right, times cos 30, right, divided by sin 30. Correct. So everything, cos 45 times cos 30 divided by sin 30, that gives you about 1.224. Everything here gives you this value. Then I'll have TEC here. Then minus, this one gives you 75, gives you what? 75 by 0.75. Sine 45, that gives 0.7071. This one gives you this. Then I have TEC equals to 20. From here, if I have 2a minus a, 1a, this gives you, it's more like saying a and a is common. Write out your a out. 2 minus 1 gives you 1. Similarly, this and this, I'll subtract this number from this. This TEC is common with this TEC. So I'm saying that 1.224, so 1.224 minus this value here, 0.7071, that gives about 0.5169 TEC, then equals 20. Make TEC subject, Divide here by 0.5169 divided by 0.5169. So this one will cancel this. So I'm saying that TEC now from here. So from here now, you're having that TEC value will be equal to 20 divided by 0.516. 20 divided by 0.5169. That gives TC is equal to 38.6 Newton. So I've gotten TEC value. So let me put it here. So TEC value gives you about 38.6 Newton. Alright, if I've gotten TEC as this value, I can get what? TEG. How? Go back to equation 3. TEC is now known as this. If I put this value here, I can get TEG. So I'm saying is put TEC, this value, as 38.6 into equation 3. Why? To get TEG. From here, TEG will be equal to TEC then cos 45 all over sine 30. From here, TEG will be equal to TEC, of course, 38.6 then cos 45 all over sine 30. If I punch this numerator, all right, take this off. All right, if I point this gives you TEG equals to, if I point this value, 38.6 cos 45, this gives you 27.29294 all over sine 30. Sine 30, this gives you 0.5. Hence, TEG will be equal to, let's see, 27.294 divided by 0.5. This gives you 54.5 Newton. All right. So I'll come here, I'll put TEG. So TEG equals 54.5 Newton. So from here, TEG gives you the value. TEG gives you 54.5 Newton. So I've recorded the values here, right? So the only thing left here is to get the value of TCD. I've got it. See, listen, yes, I did. If I get TEC, the same value work with TCE. So I'm saying this please note that what we got was TEC. Note that TEC is something as saying TCE. They are both the same, right? So I don't have to stress looking for TEC again. I've gotten TEC already. I don't have to stress myself looking for TCE. TCE and TEC are the same value. You know that what I'm saying, that the value of TEC now is same thing as what? 38.6 Newton. So I'll sketch out section C, point C. I'll pick up point E, pick up point C, and so we'll get. Take this off. And by the way, we need to get our Newton here, our weight here for B. All right.
Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, As you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
All right. From here, this gives you, pick out point C. Um, Pick out C, join C. For C, I'm saying this. Just observe this stuff. I'm saying this. This line is going this way, so that's going this way. The angle here is 45. Here is 45. So for point C, I'm drawing out the figure diagram. So this is it here. This one is called TCE because from joint C to E, this TC. Observe that there's an underline this way. This one here is your weight. So I'll call it WB. WB, weight at B. This line is going this way, right? This way, right? So it's here like there. I don't know the angle to which this line is to the horizontal. I don't know the angle here, right? So I'm saying that for this one now, I have this. I'll call it C to D. That gives you TCD. But I don't know the angle. What I know is this triangle. So triangle is given. Here is 5. Here is 4. And here is 3. So let me call this place here angle theta. Pick out this stuff. If I pick out this triangle concept, this is 5 here, this is 4, this is 3, and this is where my angle is, right? If I apply SOHCAHTOA, go back to SOHCAHTOA, right? So I'm focusing on SOHCAH, right? So for sine, that gives you sine theta equal to opposite is 3 over hypotenuse is 5. Also, for cos theta is equal to adjacent is 4 all over hypotenuse is what? Is 5. So for this triangle, try to get the cos and sine. So I'm going to the sine and cos for that triangle. So I'll come here. The sine theta is of course 3 over 5. The cos theta is of course 4 over 5. All right, let's solve this man. So if the angle is here, so it means that if the angle is here, it means that for this diagram, the angle will be here automatically. The angle theta will be here, right? The angle, let me draw this for clarity. So the angle will be here because of the triangle. Here is 5, 4, and 3. So the angle is here, so automatically it will be here. So just like that, I'll now apply my condition of equilibrium to solve this place. So for every triangle you see, try to get the sine and cos of it. So let's apply condition of equilibrium. Summation of horizontal component, that gives you summation of f of x equals 0. At this point here, if I resolve TEC to the horizontal, that gives you TCE, of course, cos 45. If I resolve this TCD to the horizontal, gives you cos because the angle is on the horizontal, but it's negative. This is second quadrant. We say we have positive y and negative x, so x will be negative, horizontal negative. If I resolve this to the horizontal, if I resolve this one to the horizontal, gives you cos. That gives you TCD cos what? Theta is the angle cos theta equals 0, right? Next task there is that from here we said TCE and TEC are the same thing. So TCE now will now be 38.6 cos 45 minus TCD. Cos theta. Cos theta is just what? 4 over 5. That gives you 4 over 5 equals 0. If I point this value, if I point 38.6 cos 45, this gives 27.29 minus 4 over 5 gives you 4 over 5 gives you 0.8 TCD equals 0. Make this a subject of formula. This is the year. I'll have 0.8 TCD equals 27.29 divided by 0.8 divided by what? 0.8. This cancel this. So TCD will be equal to 27.29 divided by 0.8. That gives 34.1 Newton. All right, I've gotten TCD. So I'm saying that TCD is equal to 34.1 Newton. So I've gotten the tension force on each cord. The lesson there to get what? The weight at B. All right, that's our applied second condition of equilibrium to get that value. Welcome guys, I just launched a course. The course will teach you how to start your own YouTube channel. If you're a teacher also trying to do what I'm doing, you can get this course. The course costs about just 10,000 naira. You can get a course and you start uploading your videos on YouTube. Or if you're a beginner trying to explore YouTube and you're having interest in learning how this YouTube of a thing works, you can do well to get this course. As you can see the banner of this course in the video, in the screen of the video, right? So do well to go and get the YouTube course so you can earn, learn, and also grow your platform. See you guys. If this interests you, do well to message me up or click on the link you see in the video description that says YouTube course. See you guys in next page. Let's apply second condition of equilibrium to get a value of the weight here. So summation of vertical component, that gives you summation f of y equals 0. For y, if I resolve TEC to the vertical, that's y-axis to the vertical, that gives you TEC sine 45. That gives you TEC sine 45. Done. If I resolve TDC, this force here, to the vertical, that gives you positive TCD, then sine theta. Positive TCD, of course, sine theta. Of course, WB is going downwards, negative direction. That gives you minus WB equals 0. Here's the idea and the concept. I've gotten TCD as this value. I've gotten TEC at this value. If I put them here, I can get the value of what? WB. So make W subject. Take WB here. That gives you WB equals TEC sine 45 plus TCD sine theta. Get value of WB. WB equals to TEC, that's 38.6 sine 45 plus TCD, that's 34.1. Then sine theta. Sine theta is what? Sine theta is what? 3 over 5. 3 over 5. Alright. WB will be equal to, if I punch calculator, let's see what we get here. If I point 38.6 sine 45, 38.6 sine 45, that gives you 27.29 plus, let me punch 31.1, 34.1 in a bracket, 34.1 um, into 3 over 5. This one gives you 20.46. So WB will be equal to, if I add this value up, let's say we get, so to get WB, what do you do there? This one here gives this, right? Let's confirm this. 3 divided by 4 times 3 divided by 4, that gives you 0.75. So 0.75 times 34.1, that gives 25.5. All right, 25.57. Add them up, what do we get? 27.29 plus 25.57. WB gives about 52.8 Newton. So the value of the weight B is of course 52.8 Newton. This is how you get the tension of each cord and also the weight at B. This is how you solve this particular problem. If you found this class helpful, do well to like this video, share to your friends, subscribe to this channel, and then also leave a comment to this video. See you guys in our next class. We'll look at example 3 in the study of equilibrium of a particle.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.